Hello and welcome back. Hey, the good news is this is our last section before getting ready for our semester final and break. This is good news, isn't it? So we're going to be starting actually the addition rule. We've been talking about probability, and if you kind of keep it simple, that it's the number of successes out of the number of total possibilities, makes it very simple. The difficult part about probability is that you have to count how many possibilities there are and make sure that you're not counting things twice. To that end, today we're going to find the probability of compound events, this or that, this and that. And we're going to learn about the addition rules that we have. So pretty easy. I think you're going to get it no problem. The key concept of this section is the addition rule as a device for finding probabilities that can be expressed as probability of A or B. And that's the probability that either A or B occurs, or they both occur as a single outcome of a procedure. The key word in this section is or. It is the inclusive or, which means either one or other or the both. So compound event is any event combining two or more simple events. So this is what we're talking about with the addition rule. Notation A or B. Probability in a single trial that event A occurs or event B occurs or they both happen. What does the term mutually exclusive events mean? So this is where you'll first start with your notes. Mutually exclusive means that they cannot occur at the same time. Another term for this, it's not in your book, but they're also called disjoint events. For example, a person cannot be an atheist and a Christian at the same time. Thus, these are mutually exclusive events. I would have said male or female, but there's hermaphrodites, so there you go. You can't use that one as a mutually exclusive thing either. So general rule for a compound event, and when finding the probability that event A or B occurs, find the total number of ways A can happen and the total number of ways that B can happen, and find the total so that no outcome is counted more than once. This is important, and this is a general rule, because I noticed on some of the activity 4.2a that people were counting things twice. When we found the probability of a 3 or a diamond in last section's notes, we had to subtract 1. 4 plus 13 minus 1 is 16 out of 52, not 17 out of 52, because there was also the 3 of diamonds. Once you count how many diamonds there are, you have a 3 of diamonds in there. We had to subtract that so that we didn't count that twice. Another example would be rolling a 4 or an even number on your dice. So give an example of finding the probability of two events that are not mutually exclusive. If they're not mutually exclusive, then they can occur at the same time. So if you had the 3 of diamonds, probability of 3 or a diamond, that's one example. If you're looking for the probability, and this is what we did in the last section's notes, 16 out of 52 or 4 out of 13. We had to subtract 1 so that we didn't count the diamonds twice. An example of finding the probability of two events that are mutually exclusive would be drawing a queen or 3. And so that is 2 out of 52. Let's look at this 4.15. Determine which events are mutually exclusive and which are not when a single die is rolled. Can they happen at the same time? If they can happen at the same time, they are not mutually exclusive. Getting an odd and an even number. This one is not mutually exclusive. It is not possible to get an odd and even number at the same time. They actually found the probability of that, since it is not even possible to get those. It's 0. Getting a 3 and the reason that's 0 is because you've got probability of odd and even. If it was or, it'd be 6 out of 6. Getting a 3 or getting an odd number, those are not mutually exclusive. And 3 is an odd number. So the probability of 3 and odd is 1 out of 6. Getting an odd number and getting a number less than 4, that means 3, 2, or 1. 3 and 1 are both odd numbers. So probability of odd and less than 4 would be 2 out of 6 or 1 out of 3. So there would be your probability. Getting an odd number and getting a number less than 4. Because you can have a number that's less than 4 and an odd number. They can occur at the same time, so they are not mutually exclusive. Getting a number greater than 4 and getting a number less than 4. Not possible. No es posible. These are mutually exclusive and it's not possible, so the probability is 0 again. Okay, I want you to try this example in your notes. Try this one on your own and I will check it and see if you understand it. Remember, there's 52 cards in a deck and you have that the whole deck laid out in your book on page 179. Addition rules. So this is when you add probabilities together. First off, if the events are mutually exclusive, then you just add them together. No problemo. Probability of A or B is probability of A plus probability of B. Addition rule 2 is if they are not mutually exclusive, that means you have to subtract off something that you counted twice. So probability of A plus probability of B minus this part where they overlap, where they can occur at the same time. So you have to add that. Some people only use this, and this addition rule 2 is known as a formal addition rule, property rule. And if they're mutually exclusive, then that means the probability of them occurring at the same time is 0. So it works for all of the different probability problems. So in other books they call it the intuitive addition rule, so that you are finding the sum of the number of ways the events can occur and adding in such a way that every outcome is counted only once. Probability of A or B is equal to that sum divided by the total number of outcomes in the sample space. This is the formal addition rule. Like I said, the other books, that's what they call it, where you subtract off that thing. Let's do one with donuts. Oh, donuts. I love donuts. Krispy Kreme. All right, in the following events, the events are mutually exclusive. Therefore, we're going to be using addition rule 1, which means we just add together the two probabilities to get our final probability. So a box contains 3 glazed donuts, 4 jelly donuts, 5 chocolate donuts. If a person selects a donut at random, find the probability that is either glazed or chocolate. So what we're going to do, total donuts, it's a dozen. If you add them up, 3 plus 4 plus 5, it's going to be a total of 12. And the probability of a glazed or chocolate, we'd say the probability of the glazed plus the probability of the chocolate. Glazed, you have 3 out of 12. Chocolate, you have 5 out of 12. So you'd have 3 over 12 plus 5 over 12. That's 3 plus 5 divided by 12, or 8/12, or 2/3. Divide the top and bottom by 4. Bada boom, bada bing. It's as easy as that, folks. I want you to try the next one about a political rally. Don't like politics, so you do that one. Day of the week, I want you to do that one as well in your notes because I think you can figure it out. And let's go onward to when they're not mutually exclusive and you have to actually subtract their overlap. So we must subtract one of the two probabilities of the outcome that are common to both events since they have been counted twice. Single card is drawn from a deck. Find the probability that it is a king or a club. So when you do this, you've got a total of 52 cards. The probability of a king or a club, you're going to have probability of it being a king, probability of it being a club, and minusing off the probability of it happening at the same time. So probability of it being a king, there's 4 kings in a deck, so that's 4 over 52. Probability of it being a club is 13 out of 52 because there's 13 clubs in the deck. But there's also 1 king and club in the deck, that 1 king of clubs, so you have to subtract that off. So my final answer is 16 over 52, or 4/13. Here's one where you have to kind of put a chart, and charts and tables are great for organizing information when you're trying to figure out the probabilities. They've got 8 nurses and 5 physicians, so right away I'm going to put, okay, 8 nurses for the total and 5 physicians. 7 nurses and 3 physicians are females, so 7 nurses, I'll put a 7 under the female, 3 for the physicians, and then it says find the probability that the subject is a nurse or a male. So if you do the math, there's 8 total, 7 females, there's 1 male. 5 total, 3 female, 2 have to be male. So the total number of females is 10, total numbers of males is 3, and the total is 13. Man, the deck is stacked against the women in this case. Alright, so find the probability that the subject is a nurse or a male. So if we start out, we've got a total of 13 staff. We want the probability that it's a nurse or a male, so you take the probability it's a nurse plus the probability it's a male and minus off the male nurses. So we're going to do probability it's a nurse. How many nurses they got? 8 out of 13. Probability that it's a male. Well, you've got 3 out of 13. So we add those together and we subtract off the male nurses. So there's only one male nurse out of 13. We add those together, we end up with 10 over 13. It's as easy as that, folks. No problem. I want you to try example 422 on your own, where you have the different intoxications of a New Year's Eve party. And finally, we can extend these rules to 3 or more events. If you have 3 mutually exclusive, so they can't happen at the same time, you might have guessed you just add them up. Probability of A plus probability of B plus probability C. If they're not mutually exclusive, if I add them up, I have counted something twice. I've counted everywhere they overlap. So I have to subtract off probability of A and B, probability of A and C, and probability of B and C. And then I have to add on the mutually where they all 3 overlap, that little part, because I've subtracted it off 3 times and I need one of them on there. So if you look at a Venn diagram, you can kind of see here's event A, event B, and event C. If I add those up, you can see that I would have the overlap added and I'd have this thing added 3 times. So if I take all those away, that's where that formula comes from. All right, that's it. That's about it. Disjoint are mutually exclusive. Events A and B are mutually exclusive if they can't occur at the same time. That is, disjoint events do not overlap. Here's our total area of 1. Probability of A and probability of B. You can see that they overlap, so probability of A and B. Here's if they're, this is if they're not mutually exclusive. This one is if they are mutually exclusive. So you just need to copy those Venn diagrams on your notes. Remember, this is where they're not mutually exclusive. This is where they are mutually exclusive. And that's about it for this section. So we talked about compound events and finding the probability using the addition rules and what mutually exclusive means. Alrighty, I'll see you tomorrow.